Hello, this is the first of several videos I'm hoping to produce regarding the theory, practice and history of character encoding, so I hope this will be informative to anyone who is interested. For the time being, I'm assuming you know enough about what ASCII is to be able to write programs in it, and maybe handle ASCII strings. You're probably aware, perhaps familiar with the concept of simple character encodings which have a 1 byte per character. You probably think that a text string can be said to have a length and can be compared equal to other text strings in a manner which is well defined. You might, depending on what programming languages you're used to, you might be used to thinking of a character as a type, where the string is a sequence of characters, but you might be used to thinking of there being a type for a single character. You might have heard of Unicode, but you might have heard bad things about it. You might have heard about, for example, criticisms of the character model used for the Tamil script, for example, or you might have heard criticisms about Chinese, Japanese, Korean, and how that interacts with character unification, and you might not fully understand the reasons, or you might have had some explanation for the reasons. You might think that Unicode is somehow categorically badly designed compared to the very simple European character encodings that you might be accustomed to. You might think certain things like joiner sequences or combining marks and so forth seem complicated, or possibly even overcomplicated. You might not understand it altogether. You may or may not have used the basics of it, but you might want to understand more. If you're not familiar with the basics of ASCII, I hope to do another video at some point in the future about the early history of character encoding and the development from Morse code to ASCII, including Bordeaux code. If I've done so by the time you're watching this and you need to brush up on that, I would recommend that you watch that one. In any case, this particular video as an opening to the series of videos I hope to be doing is substantially geared around unlearning, or rather highlighting some assumptions that you probably are making without even realising it, and which you may need to reconsider when we're working with the very complicated world that is writing systems internationally. But for the time being, let's start with something you're probably familiar with, the argument, which is to say the argument about how many spaces go after a full stop. Now, how many spaces in and of itself, a bit of a weird concept. You might not have realised this if you're grown up with computers, or at the very least typewriters, and are very familiar with the idea of hitting the spacebar multiple times, but if you think about it, when you're handwriting a document, it doesn't really make sense to talk about leaving a certain number of spaces. You can leave a wider space or a narrower space, but in any case it's one space. It doesn't really make sense to talk about multiple spaces in sequence when it's just one single blank area. So number of spaces in this respect is merely a social construct, arising with the development of typewriters and maybe liner type machines, type where you actually have keys which you'd press to enter particular characters, including spaces. In particular for a printing press, you wouldn't talk about multiple spaces, you talk about spaces that are a certain fraction of an n square, which is to say which is just a square where the width is equal to the height of a capital letter, pretty much. So an ordinary space might know a third of an m or a quarter of an m, and space after a full stop might be half an m or even an entire m, and that wouldn't necessarily be seen as multiple spaces in a row, because that concept still wouldn't necessarily make sense yet. Particularly highlighting this point is the fact that the text they have on the screen at the moment is actually justified, so the space width is actually different from line to line, so the fact that the space after full stop is wider it makes even less sense to say that that's two spaces. In fact, what you've got there is actually one space, except I'm using a particular word processor which is smart enough to widen the space after the full stop for you, so you don't have to enter multiple. So, do any of you recognise what is shown here? I'll give you a hint. You may well, it's fairly likely actually that you have used this without realising it. It isn't ASCII, it's based on ASCII because it's modified, and it certainly isn't Unicode. What it actually is this. Now, this might depend on what country you're living in, but generally speaking, this is the usual character encoding for SMS text messages that don't require characters outside of this set, which is relevant when you're looking at maximum length for text. Like on the top left, you'll notice that enter the less than sign, and it's showing 159 characters left. So there's a total of 160 characters permitted, and I've entered one, so 159 characters left. On the top right, you'll notice I've entered an opening hard bracket. As you observe, that's actually counted as 2 characters, so hence it's gone down to 158. The reason for this you can see in the bottom right, where there isn't actually a separate code for the opening hard bracket. You notice it's in the same table cell as the less than sign. So what the phone actually has to enter is an escape character, which you can see just at the top in that crop section there, followed by the less than sign. And recent enough phones, I say recent enough, any remotely recent phone would recognise that as an opening hard bracket, because it isn't a character that was originally in something called GSM alphabet character encodings, so it had to come retrofitted later using the escape character, which means that it has to enter essentially 2 characters to represent the single character, and therefore it counts as 2 letters. Now you see that the retrofitted characters, all ASCII characters, actually include the euro sign as well as any ASCII characters that weren't in the original version of GSM encoding, and you'll notice that they mostly represented on top of characters which are similar, and which would therefore mean that on really old devices the text would still be marginally legible. The escape character would just show as a blank in that context, although obviously with the tilde that wasn't quite as possible, so tilde turns into an equal sign. On the bottom left, you'll notice that I've entered a pilcrow, a paragraph mark, and that character isn't in the GSM character encoding, not even with the extensions, so it's actually showing 69 characters left in a single SMS. So inserting just that one character anywhere in the SMS takes the character limit down from 160 all the way to 70. Now, reason for that is that there were 2 possible encodings. One of them is GSM alphabet and the other is UTF-16, which GSM alphabet uses 7 bits or 14 bits if it starts with an escape character per character. So for a total of 1120 bits, if you divide that by 7 you get 160, and that's where the 160 comes from. UTF-16 on the other hand uses 16 or sometimes 32 bits per character, so if you take 1120 and divide by 16 you get 70, which is where that number comes from. So the SMS length limit is actually 1120 bits, and which isn't necessarily the same number of characters. It depends on the context what the number of characters characters is, so you can't really hard define it in terms of a number of characters. You can hard define it as 1120 bits or potentially 140 bytes, although because the 7 14-bit characters aren't actually aligned to byte boundaries, it can be split across 2 adjacent bytes. It's kind of misleading to describe it like that. Now with these 2 characters, the escape character and the less than sign, being combined into a single hard bracket, some of you may well, if you hang around the same parts of YouTube as I do, be having flashbacks to a certain video in which Tom Scott accidentally vandalises a wall at Nottingham University. Now, what I was talking about there was the encoding of national flags in Unicode as emoji, where it's actually there's actually 2 regional indicators, as you see on the left, a boxed J basically and the boxed P, which when put together it becomes a representation for Japan, and where unless you prevent it using, for example, 0-bit non-joiner character to suppress a ligature, the renderer is permitted to replace that sequence with a single character, with some sort of ligature. Ligature is just where you've got a single glyph representing a sequence of more than 1 character, otherwise representing Japan, which could theoretically be, for example, a map outline, but in reality that's used for flags, national flags, so it renders, as you see on the right, as a national flag of Japan. Ligatures are not unique to emoji flags or even emoji per se in general. As you see on the bottom, some degree of ligature support is actually required for correct rendering of Arabic, because you've got there the sequence lam alef, so a la sound, and if you just put them together using normal Arabic joining behaviour, you get what you see on the row at the top, which is not actually a correct way of writing that sequence of letters, or rather you have to write it like what you see on the bottom row. So correct ligature support is not just necessary for handling emoji correctly, and indeed the fact that demand for handling emoji correctly does actually tend to improve support for other scripts as a side effect, because it basically puts pressure on companies to actually implement Unicode correctly. This is not the only or even most important way in which that's the case, but now what I'm getting on to here is that this is not exactly the same as what you saw in the GSM alphabet earlier, because it's not like a non-breaking space and a less than sign is the same in sequence is the same thing as an opening hard bracket. Rather, that's just a 2 byte or 2 septet, should I say, representation of a single character. But in this case, you've got 2 separate identifiable code points, which are essentially separate characters in their own right, the regional J and the regional P, but when put together they can form a single ligature and therefore potentially a single user perceptible character like that. So this is where you start to see that what counts as one character rather than multiple characters can be a bit woolly. Like if you just were operating within a single character encoding as opposed to converting between them, or even if you're converting between, say, a legacy Japanese cell phone carrier Shift JIS extension, which would represent the Japanese flag, using a single Shift JIS code to Unicode, which of course requires 2 code points in sequence, the difference in semantics as to what constitutes 1 code point versus 2 starts to look a bit woolly, and that's quite important, because what doesn't constitute a single character does get quite woolly at times, and what counts as one character versus multiple is in some ways a social construct. As I mean, obviously I'm not trying to say that the letter A can count as 5 different characters, but there were some edge cases besides the ones we've already seen, so I'm going to come on to this later. Now, another thing you might have noticed here is that there are a number of Greek capital letters, but there aren't any Greek lowercase letters, and the Greek capital letters don't constitute anywhere near the entire Greek alphabet. The reason for this might become more clear if you look at the Roman capital letters that I've shaded in the kind of olive colour, where those letters are actually used in the GSM alphabet, or at least intended to be used as both Latin and Greek letters, which looks the same, which for the most part is fairly defendable, because like a Y and an Y are ancestrally the same letter. The T and Tau, O and Omicron, M and Mu, H and Eta even, although the sounds have diverged quite significantly. Even the X and Chi, where the sounds actually diverged between variants of the Greek alphabet used in Athens area versus the Greek alphabet used in Italy, where Latin of course picked up on the Greek alphabet version being used in Italy, so the Chi, Psi and Psi characters are actually kind of a different way round, but that does ultimately descend from the same letter. Now, P versus Rho, on the other hand, is complete coincidence. There's the completely unrelated letters. There's only coincidence that they look more or less the same. So that one is a bit harder to justify, except purely on graphical grounds. So, I mean, suffice to say that Unicode doesn't unify any of these pairs of letters. Hence, if you're mapping from GSM alphabets to Unicode, there were some decisions you have to make as to what language are we caring about, what language the text seems to be in, and which Unicode character is it. Should this be an uppercase O or an uppercase Omicron? Which one are we supposed to map to? And indeed, issues where multiple Unicode characters map onto a single character and legacy character encoding, and even the other way round, do sometimes occur for various reasons, not just this one. Now, as I mentioned, Unicode does not unify Greek and Latin scripts in any way, really. However, it did initially unify Greek and Coptic scripts, because the Coptic script basically takes an old version, like old kind of New Testament era sort of version of the Greek script, and add a few more letters to it, which was really quite inconsistent, because Cyrillic arose in a similar manner, and Cyrillic wasn't unified with Greek. And indeed the proposal document, which I extracted this screenshot from, actually later concluded that, especially in the lowercase, modern Greek was actually less mutually legible with Coptic than with Cyrillic, because the Greek lowercase letter forms had diverged significantly from what they would have been like in, well, New Testament kind of times. You could go the other way and say that there's some argument in favour of unifying Greek and Cyrillic. Indeed, you can put forth a stronger argument for unifying Greek and Cyrillic than unifying Greek and Latin, because Greek and Cyrillic are a lot closer to each other than they are to Latin, although you still have some issues, like you've noticed bars on the eta and nu kind of, their slants kind of, and therefore how you tell them apart, kind of change between the ancient Greek still visible in the Coptic versus what they look like in modern Cyrillic. So there's still reasons why that wouldn't be a good idea. But these are the kind of decisions you have to make when coming up with a character model to create a character encoding. You have to create a model of reality before you can represent it on the computer, and not all character encodings necessarily came up with the same model in this respect. Like we saw the GSM alphabet earlier, was unifying Greek capitals with Roman capitals that they looked like, which other Greek encodings didn't do, for example. So Unicode kind of have to pick up the pieces there and come up with one way of doing it to rule them all, as it were. Now, even within Cyrillic, you can get a lot of different things that a letter looks like, and this is granted a fairly extreme example where there's a lot of things it can look like. The differences being whether something's supposed to look printed versus handwritten, whether something's supposed to look cursive or not, whether something's italic or not, and whether it's in Russia versus Bulgaria, for example. So there are all reasons why you'd use one form versus another, but these are all the same letter, believe it or not, in uppercase and lowercase, in spite of looking very different to anyone who's not familiar with the writing system. So on that note, we come onto CJK's Chinese, Japanese and Korean Unification, which is one of the more controversial things about Unicode, and it's something which there's a lot of misconception going around about. You might have heard that it's like treating Greek and Latin as the same script. It isn't. Different countries all recognise this to be ultimately Han Chinese in origin, hence calling things like kanji, kan meaning Han Chinese, ji meaning character. So they all recognise this as being ultimately the same writing system, so it's not really like pretending that multiple separate writing systems are the same writing system. You might have also heard accusations that they're treating characters the same as at the whim of the United States-based Unicode Consortium. The reality is that these decisions are made on the responsibility of the Ideographic Research Group, or IRG, operating under the International Standards Organization, which comprises experts from various different countries, including all the countries that use Chinese characters as part of their writing system. So that's not really correct either. You might have heard that it's a mistake made by Unicode, which means that you should use Shift JIS because Shift JIS didn't do that. Actually, Shift JIS did do unification. It's just that a font designed to support specifically Shift JIS is probably going to use glyphs which are close to the reference glyphs, the standard glyphs specified in the Japanese standard, as opposed to the ones specified in the other country standards. But JS did still deliberately intend the characters to be unifications of various slightly different ways of writing it, the same as Unicode does. The reason why that misconception came about is mostly because before the advent of Unicode, every font would have to basically be designed for a specific Chinese or Japanese or Korean encoding, and text in the other languages simply wouldn't show up properly at all, wouldn't show up legibly because they'd be in a completely different character encoding, so you wouldn't notice that unification was going on. But now that everything goes via Unicode, even Shift JIS, for example, was usually implemented nowadays via converting it to Unicode, so you may well end up with Japanese text being displayed partly or fully in a mainland Chinese font, and therefore you get what we see on the screen here, where the high of the two rows shows the character which is typical in mainland China in simplified Chinese, and the row at the bottom shows the character which is typical in Japan. Now notice these are very similar, but they're not exactly the same. The central vertical stroke goes through to touch the horizontal at the top and the version at the bottom, and in some cases this can mean the difference between two different kanji, so this isn't merely a quibble, though in this case it doesn't actually make a difference in the intended reading or meaning. It's just different countries can have different positions on which is the correct way of writing it. Now I've highlighted the column which gives the Unicode or UCS representations, and as you see, that still both are U+753B, that's the code which Unicode gives, the identifying code which Unicode gives to these characters, so both of them seem to be the same, but as you see below that, it's got 753B as on the road, as on given above, but you've also got different codes for different characters after it. These were actually variation selector characters, which are invisible, zero width, you can't see them, but putting it after a character, if your operating system and font supports it, can select a different version of that character depending. So there is actually a way in Unicode to represent these in a way that tells them apart should you need to do so. So it's not true that Unicode has no way of telling these apart either, it's just a fairly advanced feature to be able to do so, which not everything supports. The reason why these be treated as the same characters, they're both just simplifications of the same character, which you see on the right. Actually see two different versions of it on the right, which is the same character basically, same meaning, same pronunciation, but slightly different. And actually those two are encoded separately, if I recall correctly, and also separately from the ones on the left, but for some reason two on the left are encoded as the same character, which you could criticise, and indeed I'm not saying that this is the correct behaviour necessarily, it's the behaviour that Unicode went with, and by this point it's the behaviour we have to stick with, but this isn't categorically the right way of doing things. You have to decide upon your character model and try to stick with it as closely as possible. Now, Unicode doesn't always stick with this particularly closely for both historical reasons and also for compatibility with earlier character sets which use somewhat different character models, treated characters as different, which Unicode otherwise wouldn't have treated as different. But you might be thinking at this point that surely you should just treat all slightly different versions of characters as distinct different characters, and surely that would solve the problem. But the problem with that is that then you have to get several almost the same strings, or strings which look the same, which a human might not realise are different, but which don't compare equal, and which are represented differently, which one of them wouldn't come up if you try and do a text search or search engine search for another, or if you're using these in web addresses, then someone might use one to mimic, to spoof using another in the same way that you sometimes get scams using paypie.com with the capital I instead of the L in PayPal. It's a similar sort of problem. There's no real one solution which satisfies every usage case. It solves every problem without creating more. The problem of just not doing CJK unification, which some people might suggest without not really knowing what they're talking about, is that you end up with a vast number of characters which look the same or written exactly the same, have more or less the same meaning, or recognised as being the same character by the people speaking the respective languages, but are encoded separately, which, as you can imagine, would mean utter bedlam in that respect. So actually Unicode does often encode multiple variants of what could be considered the same character, as you see here, this being character for double-edged sword basically, where not all of these necessarily mutually legible. You've basically got like I think different combinations of 3 different components with different ways of writing the individual components, and all of these are supposed to have the same meaning, but they're all encoded separately. Though we could argue that these should be. They could argue that they shouldn't be. Neither of these is necessarily right or wrong, they just have advantages and disadvantages. But it does highlight the point that Unicode isn't as zealous with CJK Unification as some might accuse it of. Now, as I said, there's issues with different countries writing what might be considered the same character differently, and you might be wondering, is there really a European analogue to this? And whilst this isn't an exact analogue, it's useful as a cross-reference. Some of you might already be aware of what the significance of this image is. Most of you probably aren't, so I'll point it out. Now Turkish and Romanian use slightly different symbols here for this letter. Both of them have the same pronunciation, but Turkish has a fully written Cedilla. You can see it's basically the bottom half of Z without the upper bar, just stuck on the bottom of it. Some people think of it as the bottom half of the number 5 without the upper bar, whereas Romanian just sticks a comma underneath it. These aren't necessarily considered the same thing. Like in Romanian, it's not strictly speaking considered correct to put a Cedilla on it, but as you can see, this is an official Romanian document. It's the Romanian passport cover that's currently in use, I believe, and as you can see, it does indeed have a Cedilla where it's supposed to have an undercomma. So at this point, is caring about the difference between Cedilla and undercomma merely quibbling if even the Romanian government doesn't do this consistently? Maybe not. Actually, it gets even more confusing when you start talking about Cedillas in Latvian, where the Cedillas are actually expected to be undercommas, generally speaking, but then you end up with letters which, from a European perspective, would only have Cedillas in Latvian, but in Marshallese they actually have what's supposed to be a fully written Cedilla, and isn't strictly speaking correct to write it with an undercomma like you would typically in Latvian, so that causes problems as well. Because Unicode doesn't really have separate ways of writing it. It does have an explicit way of writing a L with an undercomma, but because all the Latvians and all Latvian supporting fonts are using the pre-composed L with Cedilla, that doesn't really help in terms of Marshallese support. Now, in terms of the Romanian versus Turkish, initially they were treated the same letter, but subsequently a separate set of Romanian letters with undercomma were added. Now this arguably caused more problems than it solved, because all pre-existing Romanian text, all pre-existing Romanian keyboard layouts or input methods or font support in Microsoft Windows, for example, all expecting people to be using the Cedilla point, and adoption of the undercomma representation only came in fairly gradually thereafter, which is obviously causes problems, because now you've got two different ways of representing what's supposed to be the same Romanian text, but they don't compare equal because they're using what is supposed to be different letters. So we've basically got that mess, which we just have to live with, but it does underscore the point that switching from treating two characters the same to treating two characters as different characters isn't a neutral operation. It causes problems of its own, and sometimes causes more problems than it solves. But on the topic of what isn't the same character, which of these is the odd one out? Now you might be looking at this thinking, oh, these are separate letters, what on earth are you talking about, Ha? But in reality, all 4 of them can be an umlauted O. Umlauted O, as most obvious on the top left, is kind of like an OE combined into a single character, make an sound. Actually, the normal way of writing umlauted O in Sweden, Germany, and I think in some other places is to write 2 dots above. That actually developed from an older way of doing it, which is to write an E above it. Sometimes you also see an E written inside the O, or even 2 dots written inside the O. That's a bit unusual. That's a bit less usual. In Denmark and Norway, you usually just write a slash through the O. The odd one out is actually the 2 dots, because that isn't necessarily an umlaut. In French, for example, it isn't an umlaut, it's a diacritic, which basically does the same thing to the pronunciation as sticking a hyphen before that letter, so you get Noel, not Noel. You get, or in English, you sometimes, not very commonly, but some house styles do use it to distinguish between no one, not noon, or coincidence, not coincidence, all that kind of thing. And you can sometimes see it at the end of some word names like Chloe and Bronte to indicate that's not Chloe and Bront. It's like, as I say, basically does the same thing in terms of pronunciation as if you'd inserted a hyphen before that letter, so Chloe hyphen E or Bront hyphen E, for example. Now, you might be wondering, how on earth would a letter E turn into 2 dots? Well, and on the top left here, I've got an example of current shrift, which was until like the end of World War II-ish, I think, fairly typical handwriting for writing cursive German. And as you can see, the E is basically changed into 2 vertical lines, so the umlaut is again 2 small vertical lines, so you can see how that would have turned into 2 dots, but started off as an E, because the E is being written as pretty much 2 vertical lines. Now, another thing they've highlighted is that the U and the N basically look the same, but you're distinguishing the U by putting what is pretty much a breve above it, as you can see in the bottom left. But you also notice that the U with the umlaut doesn't have the breves, whereas the umlaut, so the U with the umlaut isn't actually the same as just taking the U there and putting an umlaut on it, because you've removed the breve as well. Another thing I've highlighted is that the only difference between the C and the I is the presence and the absence of a dot, which, apart from both of these potentially wreaking havoc on Spcial Tap, would also make this handwriting completely unsuitable for writing Turkish, for example, which distinguishes between an I with a dot and I without it. Now, the fact that the U with an umlaut and the U without an umlaut aren't just adding a umlaut to the U without the umlaut is perhaps less surprising than you might think when you consider 2 things. Firstly, if you look at the bottom right, that's the Swedish alphabet. As you can see, the A with an umlaut and the O with an umlaut are actually treated as separate letters with a different position in alphabetical order to the versions without an umlaut, so they're basically just separate letters in their own right. And the second thing is that usually, and how expected this is depends on what language you're writing. Some expect it more than others, and some potentially prefer not to, but generally speaking, you wouldn't put a tittle, put the dot above an I if you're putting another accent mark, like an acute accent in this case, on it. So the accent mark kind of replaces the tittle, and indeed, if you consider that Turkish distinguishes between I with a dot and I without a dot, which causes issues with your usual routines for converting from uppercase to lowercase or the other way around, you have to use a slightly different one if you're dealing with Turkish text to preserve whether an I has a dot on or not between uppercase and lowercase. In the same way that the separate letters in the Swedish alphabet which have umlauts could be considered a version of the normal ones but with a diacritic as well, you notice that the 2 different Turkish letters, dotless I and dotted I, could also be considered I without the overdot diacritic and I with the overdot diacritic. So this raises the question not only of, is an O with umlaut 1 character O with umlaut with its 2 characters an O and the separate umlaut character that happens to be written above it. You also have the issue of whether with an I with a dot is just the ordinary lowercase I, or whether it's an I with which a dot has really been added, or whether the I and dot are separate characters in that respect. And as see below, this is a fairly contrived piece of Latin text demonstrating why people started putting dots and I's in the first place. If you look at the left, you find that you see some text which basically looks like a load of vertical lines, and it's quite difficult to tell which is part of which letter. So initially people would have started putting dots on I's to try and make that easier to read. Like, they wouldn't always have been putting dots on I's. Like, lowercase kind of developed from uppercase, so lowercase was actually later development than uppercase in some respects. You essentially finished up with the question of is a dot is a dot on the I part of the I? Is it not? Well, it depends on what language you're speaking, really. Speaking of dots above letters, you get this example from Polish. The crop part of the table at the bottom is basically talking about particular ASCII characters which are replaced with additional letters when you're using teletext in Poland. Now the thing I want to highlight here is that these are case pairs. These are uppercase and lowercase letters, and the uppercase version of a Z with a dot above is a Z with a line through it. That's not always the case. You don't always write the uppercase with a line through it and the lowercase with a dot above, but in this case you can see that they're fairly small, low resolution letters. So the concern was that there wouldn't really be enough space to put an intelligible dot above the Z unless you shrink it, like you see with the uppercase S next to it. So the uppercase has a line through it. Conversely, in lowercase, there's not as much space to put a line through it without just turning it into a blob, but there's more space above, so they put a dot above it. So they basically treat these as the same letter, although as you can see above, Unicode treats them as 2 separate letters. Because even if in Polish it might be treated as the same letter, that doesn't mean every language would necessarily accept both of them or treat both of them the same. Actually, whilst we're talking about j sounds, it's also worth noting that that's Polish, and the third one, the one with the kind of upside down hat, something called a hard check, is the version used in Czech and Croatian, and I think a few others, which is yet another way of writing pretty much the same sound, except obviously these three relative acceptabilities, these three will differ depending on what language you're using. So, but are we considering these the same character? Unicode doesn't, just to be clear, but that's, as I keep saying, that's a decision of the character model that isn't necessarily the be-all and end-all. You could put forward arguments for other ways of doing it. Now on the bottom here I've actually shown the Cyrillic character which all these correspond to. Now theoretically you could have two fonts over the same character encoding, one giving Cyrillic letters and one giving Roman letters which correspond to one another. There are quite obvious drawbacks to this approach and complications which will arise, and I'm not suggesting this approach is a good one, but it's worth bearing in mind because some historic character encodings have made similar approaches to that. And indeed, when you do this, you then come up with some quite interesting situations. Like on the left, you see a letter which is from the Serbian Cyrillic alphabet. It makes a j sound. On the right, you see what it looks like in the Serbian Latin alphabet, and you see actually Latin alphabet. Actually, you should probably be saying Gaitsa alphabet because it's not unique to Serbia. It's used in Croatia, for example, as well. But notice that it's actually got two characters, where the Cyrillic has a single character, but actually these are treated as one character. So there'll be so in the dictionary sorting order, for example, the J would be sorted separately, even though it's just written as if it were two separate characters. And indeed, this can cause problems when you're trying to sort text in alphabetical order, because you potentially need to know when something's a J in the sense of being treated as if it were a single letter. It's sometimes called a collational digraph, and therefore sorted differently, versus whether it's two letters, a D and a J, which just happen to come at one after the other. When two characters look the same, and come from the same thing and sometimes sound the same, this can cause complications as well. Like Latin A and Greek alpha are essentially very closely related letters. Or you could argue that they should be the same letter, and indeed that is some overlap in the correct way of writing it, although in some ways of writing an alphabet, lowercase alpha, which aren't correct for A. There are some ways of writing lowercase a which aren't correct for alpha, but there are some ways which are essentially correct for both of them. So on the left here you see the Roman A, on the right here you see the Greek alpha, and in the middle you see what's actually sometimes called a Roman alpha, which is different from the A in some writing systems, including some alphabets for certain languages, and also the International Phonetic Alphabet, which is all very well if you're writing a two-story letter for lowercase a, but as you can see, if you're using a font which doesn't do that, the lowercase a and lowercase Latin alpha basically look like the same thing, and there's no real way of telling them apart. But I mean, because that is in any other context which doesn't require distinguishing it from a Latin alpha, that's a perfectly acceptable way of writing a Latin lowercase a. A font's perfectly at liberty to do that. So what arises from this is that you can't really have a font which is suitable for writing all writing systems, but is also trying to establish a particular style. I mean, you saw that for the current shrift earlier with how it wouldn't be suitable for writing Turkish, but this is another example. So the final thing to think about is all these one character, two characters, three characters. Would you ever three-way distinguish between a Latin a Latin alpha, sometimes called a Latin script A, and a Greek A, or would that just be silly? I mean, probably the latter, but these are the kind of decisions you have to make when designing your character model. Now, sometimes you just get characters which are exact duplicates. Now, you can see here these are separate characters in Unicode and also separate characters in Windows Code page 1253, which is Microsoft's single byte character encoding for Greek. Now, the reason why there's two of them is that they wanted to retain the micro sign in the same place that it is in Windows 1252, which is the Microsoft code page for Western European and American Latin script. But of course, because this is the character encoding for Greek, it also includes its own mu, which is elsewhere, and it looks exactly the same, because let's face it, they're both lowercase mu's, but these are treated as separate characters. Now, Unicode does have a sort of solution for this, in that it has something called a compatibility decomposition, which indicates that these two are sort of the same character, with maybe some differences in stylization or font plausibly, although in this case they're basically the same thing. But mu's are not unique in this respect. This is just one particular example. the first 256 characters in Unicode are inherited from ISO 8859 Part 1, which is for Western European Latin script, and includes a micro sign. Now the Greek block is elsewhere. There's a separate Unicode block for Greek. I believe it's actually called Greek and Coptic for historical reasons we've already discussed. And it wouldn't really make sense to just have a hole where you'd expect the lowercase mu in the middle of the Greek block and an annotation point saying that you're supposed to look for the lowercase mu in the Latin one supplement block. You could also argue a semantic difference in whether it's a Greek letter as part of a Greek word or whether it's a part of a unit symbol or micro sign, but you don't exactly have a separately encoded lowercase k for kilo sign, so this argument doesn't really make sense in the long run. Now, on the topic of exact duplicates, the national standard character encoding for South Korea actually included a lot of duplicated characters. The reason being that whilst the character can have multiple readings, if you include native Korean readings, each character is usually expected to have one. In Korea, but anyway, it is generally expected to have one Chinese derived reading, so all the characters in the character encoding were ordered according to the Chinese derived reading. So characters which have multiple Chinese derived readings finished up and included multiple times. Now, as you can see, sometimes this involves a change in meaning and also different set of native Korean readings, so there is some argument to be made that even though they're completely identical in how you'd write it, they do represent different meanings. This is a decision which you can make in your character model, which isn't a particularly good one necessarily, because frankly, if a case should be able to just come across a character written down and be able to type it in, you should have to know precisely what the meaning is in that context to be able to select the correct character when typing it in. But as you can see, the middle two, those have the same meaning, the same Korean derived reading, and only the Chinese derived readings differ, and that's purely due to phonetic changes within Korean itself, actually not unique to this character. So you've got a load of characters which are basically pointlessly duplicated on account of that thing. This is the only one in the South Korean national standard which was included 4 times on account of this unusual design decisions, so it's fairly prominent in that respect. Now, if you look at not just the Korean national standard but IBM's corporate character encodings, there's actually another character which is encoded 4 times. Now, this one's only included once in the national standard character encoding, probably because the other 3 meanings are either archaic or fairly obscure, but because these were included in separate encodings in IBM's EBCDIC encoding for Korean, they also show as duplicates in some other IBM encodings, and this of course causes problems when you're trying to map them to Unicode. North Korea takes its own unusual approach because it actually includes separate special encodings for the characters composing the names of North Korean leaders. So, for example, the Kim character is encoded 4 times, once an ordinary symbol, and has 3 slightly bolder versions representing the surnames of the names of the 3 North Korean leaders. So again, you've got this repeated 4 times, but for a completely different reason. Needless to say, Unicode doesn't do this. And speaking of Korean, because firstly the Korean syllable block is actually a block of multiple letters arranged into a kind of block for a syllable, and because these letters can be compound letters, it's also a featural system which represents can represent one sound using a modified version of the symbol for a similar sound. How many? You could come up with all sorts of arguments for how many characters a single Korean syllable block comprises, and some of these representations are much more sensible than others, let me be clear here, but different character encodings and different character models could plausibly make different decisions in this respect. Meanwhile, in Japan, you have this, and if you thought Unicode not necessarily distinguishing between very minor variants of a character is a problem, and if you were under the illusion that Shift JIS doesn't have that problem, well, this is just a small extract from a much larger table, but suffice to say that Shift JIS has a problem much worse than Unicode, because for example, there were some characters where it swapped two variants between their code points, so they kind of swapped around as to which code point is supposed to be used for which variant. And go into details if I ever create a video on the history of JIS character coding, go into a bit more detail than that, but suffice to say that if someone tries to convince you that Shift JIS doesn't have problems with character variants and unification thereof, that's wrong. Actually, nothing could be further from the truth. Now, another thing you sometimes hear claimed about CJK Unification is that two Shift JIS strings can convert to the same Unicode string, which can be a problem if you... Actually, that has nothing to do with CJK Unification whatsoever, and it's everything to do with Microsoft's version of Shift JIS, including several characters twice delivered. It actually includes two of these characters, neither of which are Chinese characters. Both of these mathematical symbols 3 times. You might be wondering, why on earth would you want to do that? And actually, it's for historical reasons, because some characters which are included by IBM's EBCDIC encoding for Japanese weren't initially included by the Japanese National Standard for Character Encoding, and therefore weren't included by Shift JIS. So IBM added it as a vendor extension. NEC also did separately, and then sometimes later versions of the JIS standard then added it in, then added that as well. So you sometimes end up with 2 or 3 different representations of the same character between them, and then Windows just combined all of them that existed at that time. So not the 2000 later versions of the JIS standards, but earlier ones than that, and then it's up with multiple deliberate exact duplicates within the single encoding, which, as you can imagine, can cause problems. So I think the most important thing that you should take from this is that there is no universal character model. You have to make particular decisions when designing a character set as to when you want to treat characters being two characters as the same character versus when they're different characters, and what is a single character versus what is multiple characters. When is a diacritic and potentially a separate character versus when it is simply part of a letter. And not only have character encodings made different decisions on this, but for various practical reasons they've sometimes had deliberate duplicates, and because Unicode inherits some of these quirks and doesn't inherit others, it has various problems. There are various problems resulting from this if you're using converting between Unicode and other character encodings, and indeed the various approaches have benefits and drawbacks in their own right. I hope this was helpful to you, and signing off now. Bye.